Everyone always focuses on the flashy stuff, the big 8K screens, the OLEDs.
Yeah, the glass.
Exactly. But if you've ever actually worked in Pro AV, you know the real nightmare isn't the display.
Yeah.
It's the copper. It's just the simple, awful headache of getting a signal from point A to point B when they're far apart.
It is the invisible bottleneck of the whole industry. I mean, HDMI was never built for distance. It's a fragile signal, really.
Which brings us perfectly to today's deep dive. We are looking at the Kramer PT-571.
A tiny little box.
A very tiny box. It's one of their PiCo tools. And our mission today is to figure out how this thing uses DGKat technology to basically cheat the physics of a standard HDMI cable.
And cheat is the right word. Because, a normal HDMI cable starts to fall apart after, 15 feet?
If you're lucky.
Right, you get
Yep.
sparkles, signal dropouts. The PT-571 is, at its core, a twisted pair transmitter. It just takes that signal and converts it to run over a standard Cat cable.
Which everyone has. Cat 5, Cat 6. It's probably already in the wall.
It's cheap, it's flexible.
But looking at the specs here, compatibility isn't the same as performance, is it? The distance this thing can push a signal seems to change a lot.
That is the absolute key takeaway. The marketing says long reach, but the reality is dictated by the copper you're using.
So for a 1080i signal,
For 1080i, sure, you can hit 90 meters. That's almost 300 feet pretty easily.
because it's just less data intensive. But let's be real, who is installing a new system just for 1080i anymore?
Nobody. And the second you jump to 1080p, the data density shoots up, and suddenly that cable quality becomes a cliff.
A cliff, what do you mean?
I mean, if you try to use older Cat 5 cable, that 90-meter range just collapses. It goes down to 30 meters.
Wow, you lose 2/3 of your distance.
Gone, just by upping the resolution. It all comes down to signal crosstalk inside the cable.
So to get that full 90 meters at 1080p, you have to be running much better cable.
You have to. You've got to move to a shielded Cat 7 to protect that signal integrity. The transmitter can push the signal, but it can't fix a noisy environment.
Okay, now, on the installation side, I saw something I really liked. The Power Connect system.
Oh, yeah, that's a lifesaver.
Because usually with these extenders, you have a power adapter, a wall wart at both ends.
Which is just awful when your receiver is tucked behind a screen mounted flush on a wall.
There's never an outlet there.
Never. This system sends the power right over the Cat cable. You power the transmitter at the rack, and the receiver just gets its juice automatically.
So much cleaner. I also noticed they have EATed pass-through.
Crucial feature. Absolutely crucial.
Explain that for us. Why is that so important?
Well, there's nothing worse than an extender that messes with the data handshake. The source, like your Blu-ray player, needs to know what kind of screen it's talking to. EATed is that conversation.
So this unit just lets that conversation happen transparently.
Exactly. And it even gives you visual feedback, those little LEDs on the front.
The status lights.
Yeah, red for power, orange when an output is connected, and yellow when you have an active signal flowing. It's a simple traffic light, but when you're up on a ladder troubleshooting, it saves a lot of time.
And we should touch on the form factor again. PiCo tools sound small.
They are very small, but the real benefit is rack density.
Right.
You can fit 4 of these things side by side in a single 1U rack space. For a sports bar or a command center, that saves you a huge amount of space.
So to pull this all together for you listening, the PT-571, it's not magic. It's more of an infrastructure bridge.
A very smart bridge.
It lets you use that cheap long-run cable you already have to carry the high bandwidth signal you need.
It creates reliability where HDMI normally creates chaos.
And it makes me think about a bigger trend. As we all push for 4K, 8K, and higher refresh rates, the resistance of the wire itself is becoming the main enemy.
Well, physics is winning.
We rely on these little boxes to fight back, but eventually, even copper has its limit.
You have to wonder if we're nearing the end of the copper age for high-end video transport.
Something to think about the next time you see a perfect, glitch-free image coming from a projector way across the building. Thanks for diving in with us.